Okay, Unit 1, Lesson 3 notes. These are the notes that I wanted to do with you in class today. I just wanted to show you a few of these limits so that when you do your book work, it will make sense to you what to do. So this is given. They're saying it is known that this is true. So now, what is this? Well, you're probably going to have to use this to solve this, right? They wouldn't have given it to you if you didn't. So let's go ahead and try to sort out this function. Let's see if we can write it in a couple of different ways. So cotangent in the denominator is tangent in the numerator. So tangent in the numerator is the sine of 2x over the cosine of 2x. Okay, so that is what your cotangent of 2x in the denominator simplifies to. So now, I'm still trying to look, how am I going to use this? And so I see the sine of 2x here, and I see that this could be considered 4 times 2x, right? So I kind of have a 2x there. So let me think what I would have to do. Since I don't need that 4, but I do need the 2x, I'm going to bring 1/4, and the 4 is in the denominator, so it comes out as 1/4. I'm going to go ahead and move the sine of 2x to be first, and I'm going to put cosine of 5x second. I'm going to leave this 2x. Now, look, 4 times 2x, that's still 8x in the denominator. And I'm going to just add another limit on there. So I've got my cosine of 5x over my cosine of 2x. Okay, so that is how you kind of split that 8x up into 4 times 2x, and you keep the 2x with you, because now I know this limit right here. I'm going to bring down my 1/4. I know that limit is 1. And then I'm going to use direct substitution here. If I put 0 in, the cosine of 0 is 1. If I put 0 into this one, the cosine of 0 is 1. So that becomes 1 over 1. So then when you multiply all those out, you get your answer of 1/4. Example number 2. Again, they have given us that you know that the limit as x goes to 0 of sine 2x over 2x is 1. I am going to have to use it to solve this problem. So let's start by just breaking everything down into sine and cosine. So tangent is sine of 2x over cosine of 2x. I've already got my 6x. I'm just going to move that, this part right here was already there, so I'm going to move that in the front of cosine. Secant of 3x in the denominator is cosine of 3x in the numerator. So now, remember, you're looking for sine of 2x over 2x. So if you're thinking of this as, ooh, this is 3 times 2x, that 3 is in the denominator, so you could bring 1/3 out. This would be the limit as x goes to 0 of sine 2x over 2x, and then times the limit as x goes to 0 of cosine 3x over cosine 2x. So bring the 1/3 down. This limit we know is 1. And this limit, if I use substitution, I would get the cosine of 0, which is 1, over the cosine of 0, which is 1. So this all simplifies to 1/3. Example number 3, we've got the limit as x approaches -4 of x plus 4 over x cubed minus 16x. If we use substitution right now, we're going to get division by 0. So that's what we're going to try and not get. So I'm going to factor an x out, and I'm left with x squared minus 16, which we know can be factored. And then our x plus 4s can cancel. So we're really looking at the limit as x goes to negative 4 of 1 over x times x minus 4. Now you can use substitution. If I put my negative 4 in for x there, and I put a negative 4 in for x there, I end up with 1 over negative 4 times negative 8. I end up with 1/32. And our last problem, I wanted to name them A and B. I just didn't get a chance to do it. And we're going to start with this one. So the first thing we're going to do is put it so that it's the limit of the numerator divided by the limit of the denominator. That's your first step. And your next step, the whole thing can be taken to the second. That's one of those rules for limits. Okay, so I can do that. And then I don't like that 3 there. I'm going to bring that 3 out in front. So it's going to be like, I can't take it out of the squaring, but I can leave it inside that square like that. Okay? The denominator can just be split up. Limit as x goes to 0 of 4 minus limit as x goes to 0 of f of x. And so the limit of a constant is the constant. So that's 4 minus, and then now we're going to have to put in whatever that limit as x goes to 0 of f of x is. So let's find the limit as x goes to 0 of g of x is 2. And the limit as x goes to 0 of f of x is negative 2. So 6 squared over 4 plus 2, 36 over 6, you get 6. Now for part B, that limit, you can bring the square root on the outside. And this would be 2 times g of x minus f of x. So I like to bring that 2 in front. And then minus the limit as x goes to negative 2 of f of x. So now let's go up here. G of x when x is negative 2 is 6. Oops, sorry. And f of x as x goes to negative 2 is 4. And that can be written as the square root of 4 times the square root of 2. So it simplifies to 2 root 2. Okay, so let's go ahead and think about that function sine of x over x, okay? And I'm going to go to Desmos. Oops. And x out of that. And we're going to put in y equals the sine of x divided by x. And you can see it still kind of looks like a parabola. It just kind of approaches 0 as you go to infinity. But when you get close here and you're approaching 0 from the left, you're getting some values. There I am approaching 0 from the left. Oh, at 0, it's undefined. You see that? So that means it technically has a hole here. So it doesn't matter if I decide to change my my value to 2x, let's say, or it could be 5x over 5x, or it could be 3x over 3x. Notice that you're still going to have that same, 0 is undefined. And so if I approach 0 from the right, I'm going to get 1. If I approach 0 from the left, I'm going to get 1, even though the function's value is never going to be 1. So a lot of times we use that when we're working a limit problem. So one limit that they want you to memorize, the limit as x goes to 0 of sine x over x equals 1. That is a very important limit, and you have to remember this can be anything as long as this is the same thing. So the limit, you're going to, in the book problems, you're going to see something like, it might say the limit of sine of 5x over, 3x or something like that. And you're like, well, this isn't a 5. That's not a 5. Problem, problem, problem. So I need a 5, but I can only multiply by a fraction that equals 1. So I'm going to multiply by 5 over 5. The top 5 is just going to get pulled out front. This bottom 5, I'm going to leave it there with the x, and I'm going to take that 3 and move it out front. And so now you can see, wait, I know this limit. It's 1. So 5/3 times 1, my answer is 5/3. Okay, so sometimes you have to pull things out of the air and you're like, wait, how am I supposed to know this? Well, you are. You're supposed to just know it. But these are kind of fun problems. There's similar ones on your book work, and so I will assign that. Thank you.